What mass of oxygen is required for the complete combustion of 74.06 grams of octane? Now, we're going to have to write the balanced equation of the combustion of octane first. So C8H18, and then combustion means plus oxygen gas, which is a diatomic, and will always yield the same two products, CO2 and H2O. Now we need to balance the equation. We're going to have 8 carbons on the left, so 8 carbons on the right, 18 hydrogens on the left, so 9 times 2 is 18 hydrogens on the right. And now we have 2 oxygens on the left, but we have 8 times 2 is 16 plus 9 equals 25 oxygens on the right. So 25 is an odd number. So 25 divided by 2 times 2 would give me 25 oxygens on the left-hand side. But we can't leave this as a fraction, and so we'll go ahead and multiply all coefficients by 2. So 1 times 2 is 2. 25 divided by 2 times 2 is just 25. 8 times 2 is 16, and 9 times 2 is 18. And so we have a 2, 25, 16, 18 ratio for this balanced equation. So we are given the amount of octane as 74.06 grams and asked to find out how much oxygen will that consume. So we'll be stoiching from octane to oxygen. We'll put our given 74.06 grams of octane over 1. Bring down grams of octane. We're going to go to the periodic table and get the mass of carbon times 8 plus the mass of hydrogen times 18. And that's going to give us 114.26 grams, which equals 1 mole of octane. Now we can do our mole-to-mole ratio between octane and oxygen. There are 2 moles of octane and 25 moles of oxygen. And now I can convert from moles of oxygen to grams of oxygen by going to the periodic table and taking the mass of oxygen times 2, which is going to give me 32. When I plug this into my calculator to solve it, I get 74.06 divided by 114.26. It's going to be times 25 divided by 2 times the 32. And that gives me 259.3 grams of oxygen, which is letter E.